Welcome to this session. This class, we're going to discuss about two problems on determination of residues of function from definition. So our first function is f of x, f of z equals to z cosine of 1 over z. And then we have to determine the residue at the point z equals to 0. In the next problem, we have to find the residue of the function f of z given by z cubed over z squared minus 1 at infinity. So it's like saying residue at z equals to infinity. Now let's discuss the first solution. So solution, by definition, residue of f of z at the pole z equals to a is given by the coefficient of 1 over z minus a term. So in our case, we have z equals to 0. So it implies residue at z equals to 0 would be the same as coefficient of 1 over z, because z minus 0 gives z. In the series expansion, for this solution to the first problem of f of z given by z times cosine of 1 over z. So the equation now reduces to knowing how to write cosine of 1 over z in series and then multiply by z. And then from that given solution, you identify the coefficient of 1 over z. So we know that the series for cosine of a function x is given by 1 is given by x minus x squared over 2 factorial plus x power 4 over 4 factorial minus x power 6 over 6 factorial plus other several terms. So this implies that cosine of 1 over z will be given by, now the role of x is taken by 1 over z, so we'll have 1 over z minus, so the square of this one will have now 1 over 2 factorial z squared plus 1 over 4 factorial z power 4 minus 1 over 6 factorial z power 6 plus 1 over 8 factorial z power 8 minus other several terms of the same pattern. So which implies that z cos of 1 over z will be z times this series 1 over z minus 1 over 2 factorial z squared plus 1 over 4 factorial z power 4 minus 1 over 6 factorial z power 6 plus 1 over 8 factorial z power 8 minus other several terms of the same pattern. So when we multiply every term by z, we get z times cosine of 1 over z will be 1 minus 1 over z 1 over 2 factorial z plus 1 over 4 factorial z power 3 minus 1 over 6 factorial z power 5 plus 1 over 8 factorial z power 7 minus other several terms in that given pattern. So we are only interested in the coefficient of 1 over z, and you see this is the same as writing 1 minus 1 over 2 factorial times 1 over z plus 1 over 4 factorial 1 over z power 3 minus 1 over 6 factorial 1 over z power 5 plus 1 over 8 factorial 1 over z power 7 minus other several terms. So our coefficient of 1 over z is minus 1 over 2 factorial. 2 factorial is just, so coefficient of 1 over z is negative 1 over 2 factorial, which is just negative 1 over 2. So therefore, from definition, the residue of f of z given by z cosine of 1 over z at 0 is negative 1 over 2. So that's the solution to that given problem. And then question 2, we had f of z was given by z cubed over z squared minus 1, and you are interested with finding residue of the function as z approaches or at infinity. So we have, so the trick is to write f of z given by z cubed over z squared minus 1 as a series, then identify the coefficient of 1 over t, where t is actually can be defined by z minus a, where a is infinity. So, and from definition, residue at z equals to infinity is given by negative of the coefficient of 1 over t. So let's discuss that. So solution, our function f of z is given by z cubed over z squared minus 1. So we can derive this function as z cubed over z squared into 1 minus 1 over z squared. And you see this is the same as z over 1 minus 1 over z squared. Because z squared cancel z power 3 z times. Now we can say that f of z is z and then 1 minus 1 over z squared. Now remember the power of this one is 1. So when you take it to the numerator, then it will be negative 1. And by binomial theorem, we know that if we have 1 minus x power minus 1, this is the same as 1 plus x squared plus x power 3 plus x power 4 plus x power 5 etc. So this is by binomial theorem. So letting x to be 1 over z squared, then f of z is given by z into 1 minus 1 over z squared for negative 1 is the same as z into, now we write this one as this series, 1 plus 1 over z squared plus 1 over z squared squared z power 4 plus 1 over, so power 3 will be z power 6 plus 1 over z power 8 plus 1 so over z power 10 plus other several terms. So when you multiply every term by z, our f of z will be z. Now this crosses 1, so we'll have 1 over z plus this will give us 1 over z power 3 plus 1 over z power 5 plus 1 over z power 7 plus 1 over z power 9 plus other several terms. So this implies coefficient of 1 over z is 1. So from definition, the residue at z equals to infinity is given by negative of coefficient of 1 over z, in this case, i.e., this will be negative of 1, which is negative 1. So therefore, the residue at infinity, hence the residue at infinity for the function f of z given by z cubed over z squared minus 1 is negative 1. So that is how we solve that problem. Thank you.